Lesson 19, Introduction to Quadrilaterals. Usually mistakes people make when talking about four-sided figures is that if I say, hey, what do we call a four-sided figure? People blurt out like the first thing that comes to mind, and usually the first thing that comes to mind is rectangle, square, right? And that's not what we call a four-sided figure or a four-sided polygon. Four-sided polygon is called a quadrilateral because not all four-sided figures are squares. They're not all rectangles, all right? And quadrilaterals holds a lot of different categories inside of it, okay? They can be classified according to the number of congruent and parallel sides that they have. Okay, I know it seems kind of like maybe boring information. I can't really jazz it up too much more for you. Okay, so you have really essentially three types of quadrilaterals four, based upon number of congruent and parallel sides. First off here is we have parallelogram. Basically means I have two sets of opposite sides that are parallel to each other. Parallelograms hold several different categories that fall underneath the umbrella of parallelograms. So your rectangles, your squares, and your rhombuses all fall underneath parallelograms. Okay, and so you'll get future lessons that talk about parallelograms in specific. Today we're talking about them in general. Okay. All right, then we have kites, and I couldn't come up with like a really good shape for a kite that I could just pull up. So really a kite is better represented by something that looks like this than by what you see over there, because that just looks like an elongated diamond. So this is a better picture here in blue. So it has exactly two pairs of congruent consecutive sides, so sides that are right next to each other or sides that share a common vertex. All right. Those are going to be congruent to each other. So notice this isn't, a kite is not a parallelogram, right? It does not have two pairs of opposite parallel sides. Then we have a trapezoid, which has exactly one pair of opposite sides that are parallel. And there are different types of trapezoids. We have isosceles trapezoids, those types of things. And then we have a trapezium. A trapezium is basically anything else. Right? It's not a parallelogram, it's not a kite, it's not a trapezoid. It's just an odd-looking four-sided polygon. Okay, am I like talking you to sleep? Okay. Hey, here's the great thing about that though, is if you do have trouble sleeping, evidently you could probably just pull up one of my YouTube videos, right, and just fall off to sleep. Right? Oh man, play the one about quadrilaterals. That puts me out every time. Okay, it's like Ambien. Don't even need to take drugs now. I just listen to his videos. And then I would probably get a whole bunch more views, right? I'd get like thousands of views because it just put it on my channel and just play like one after another. That's right. Whatever that is. I have heard of it, but all right. So in addition to quadrilaterals, you wouldn't believe how hard it is to say quadrilaterals, and especially if you have to say it like 100 times a day. Addition to those listed earlier, there are three types of parallelograms. Okay, so again, we're breaking this down. So all this fits inside of that category. Parallelograms are classified based on whether or not their sides are congruent and whether or not they have right angles. So not everything is a rectangle. Okay, rectangle. We'll get future lessons that deal just specifically with what makes a quadrilateral a rectangle. Okay, a lot of mistakes get made because we see something and we assume that it is that because it looks like that, right? When in technicality we don't have enough information to prove that. Right? Just because something looks like a rectangle doesn't mean that it is unless it fits the rules. So a rectangle is a parallelogram, meaning the opposite sides are parallel, and that's forced into being because it has four right angles. Okay? So a square is a rectangle. A rectangle is not necessarily a square. Okay? So a rectangle is a four-sided polygon with four right angles. That's as far as we're taking it today. Okay? All right. A rhombus, okay? A rhombus is a parallelogram that has four congruent sides. All sides are congruent. It does not necessarily have four right angles or four congruent angles. Doesn't have to. All it has to be is a four-sided figure with four congruent sides. Okay? Which that's typically what people get confused with a square. A square has to have both of those things. Okay, so a square is a rhombus, a square is a rectangle. Not all rectangles are squares, not all rhombuses are squares. Some rhombuses are squares. Some rectangles are squares. Okay, but rectangles involves a much broader sense. A rhombuses involve much broader group. Okay, but a square is something very specific. Okay, does that make sense? So not everything is a square. All right. Let's see if we got anything else in here. Some quadrilaterals can be named in several ways. For example, a square, like we said, is what we've got here. But interestingly enough, a kite can be considered a trapezium because if we go back to our definition of what a trapezium was, is it just had no sides are parallel. Well, a kite also fits under that category, even though it's its own independent thing. Right, it fits into those two categories. So when we talk about kites in specific, we actually don't talk about trapeziums very much. All right, so in terms of needing to know that term for a test, probably not. Okay, we don't spend a lot of time there, but you do need to know kites, trapezoids, and parallelograms. I would say that between those, you probably need to know parallelograms the most. Okay. If a rectangle has a base of b and a height of h, then its area is base times height. Again, hopefully stuff that you already know, right? How to find the area of a rectangle, length times width, base times height. But because in a square all sides are congruent and a square is a rectangle, I don't have to say base times height because the base is the height. The height is the base. They're the same thing. So if I'm trying to find the area of a square, it's just find the length of the side and square it. Side times side. Okay? So its formula is A equals S squared, but you're not going to get it wrong if you did base times height or length times width. All right, that's it for that. Let me see if I probably don't. Here we go. And that's not even what we need. So let's get rid of that. You might see some questions here from lesson 20, and that's fine. All right, so find the area of a rectangle. This should feel really good, right? Like, holy cow, I'm in geometry, and I'm getting to do stuff that's like 4th grade math, right? But that does mean at this point, what's that? They never taught you how to find the area of a rectangle in 4th grade? Okay, I'm sorry. 6th grade math. You're getting to do 6th grade. What's that? Mr. Spears taught you guys how to find the area of a rectangle? All right, then you guys should be able to tell me how to find the area of this rectangle. All right, I'm being told that D is correct. How did you find it? Just verbally. All right, 16 times 7.6 comes out to 121.6. Okay, very good. Okay. Again, this is why you want to listen to the video and not just watch it. All right, Katie. There's a reason I'm asking you this question, right? Okay. All right, find the perimeter of the rectangle. What do I want to do here? Add up all the sides, right? We want to read the question carefully and not just assume that we're going to find the area. All right, so go ahead and add up all the sides for me. What do you get? 45.5. Well, 45 plus 45 is 90, right? 0.5 and 0.5 is 1, so that's going to give me 91. Okay, so I can go ahead and put 91 up here. Maybe. Okay, there we go. 38 and 38, I think, is 76, right? So 0.5 and 0.5 is 1, so that would be what, 77? something like that. And 9 and 7 is going to be 168. See if that matches. $168. Okay. All right. Let's see. Here we are given a word problem, no picture. The rectangles on a quilt are 2 inches wide and 3 inches long. The perimeter of each rectangle is made by a pattern of red thread. If there are 30 rectangles in the quilt, how much red thread will be needed? Okay, so we need to find the perimeter of one square, or one rectangle, I'm sorry, and do what with that? Multiply by 30, all right? So in a rectangle, opposite sides are congruent, correct? Okay, so 2 plus 2 plus 3 plus 3, 10, 10 times 30, 300 inches, right? Does that make sense? Okay, good. So we can make common sense out of a word problem. We don't need biconditionals because that's not this lesson. Maximum, okay, this is a good question because this allows me to address something that's not addressed in this lesson. The maximum area of a quadrilateral is a square, okay? We can take the dimensions of, let's say that we have, in terms of perimeter, right? This might have the same perimeter as that. Does that make sense? But this will have a greater area. A square makes the biggest area out of any given perimeter. Okay, so you see questions like this. What is the maximum area of a rectangle with a perimeter of 164 centimeters? What we want to do, given a question like that, okay, is we need to find basically what the sides would be to make that a square, right? So if I've got 164 all the way around and I want to make a square out of it, that means all 4 sides have to be equal, correct? So take 164 and divide it by 4. Okay, well that should be what, 41? 41. So each side is 41 now. And so I'm going to take 41 times 41, or 41 squared. 1681. Now, it would have been easy to kind of duped into this is on a test, so I'm just going to pick the largest area that shows up there. They put 26,896 centimeters squared up there to trap you. Okay, if you don't know how to do it, you can't just pick the largest number. Okay, does that make sense? They pick another one that's really, really close to it that isn't it, with 1680. All right, do we understand this question? All right, okay. All right. All right, number 7. Okay, Jose, farmer wants to build a rectangular garden 10 feet long and 6 feet wide. How many feet of fencing should he buy? You want to go ahead and take your headphones out for me? Thank you. All right, what are we trying to solve for? Perimeter. Okay? So go ahead and tell me what perimeter he should have. 32 feet, right? 10 and 10, 6 and 6, 20 and 12 is 32. Good. All right, so 32 feet. Okay. All right, determine the perimeter and area of this rectangle. So 3.5 and 3.5 is what? 7. 5 and 5 is 10. So what do I have for perimeter? 17 centimeters. Okay, we've got 5 times 3.5. What's that, 17.5? Right, because 3 times 5 is 15. 0.5 times 5 is 2.5. 2.5 plus 15 is 17.5 centimeters squared. Okay? Okay, a quadrilateral ABCD, each side measures 4 meters. What kind of shape am I going to get if I were to sketch that? Or actually, okay, so we could sketch a square, okay, but they're not telling me that it's right angles. So at the very least, what should I be drawing? A rhombus. That's exactly right. Thank you guys for listening closely, because the only quadrilateral that tells me for sure that all 4 sides are congruent in the most general terms is a rhombus. Does that make sense? Okay. All right, we don't need number 10, not for today anyway, and so that's it. All right, does this make sense? Seems really easy. Probably could have shoved it in with another lesson and still been fine, but it's kind of nice to take a break, get an easy lesson. All right. Diffuse some stress.